And welcome Geometry to Chapter 1, Section 2, Measuring and Constructing Segments. Please pause the video and try the warm-up. Come back when you're ready to answer the questions. Number 1, 7 plus 3 is 10. Good. Number 2, negative 1 plus 13 is 12. Number 3, the absolute value of negative 7 minus 1. Negative 7 minus 1 is negative 8. The absolute value then is 8. Good. Number 4, when you gather like terms, you end up with 7x equals 14, so x is 2. Number 5, once again, if we gather like terms, subtract 3x, x equals, add 5 to both sides, x equals 5. And number 6, how many real numbers are there between these two fractions? And recall that real numbers are all of our rational and complex numbers, and so that includes fractional, right? So there are infinite fractions that could be created between half and 3/4. Isn't that interesting that there are infinite real numbers between these two numbers? And there are also infinite numbers outside of those. It's kind of interesting. So our ruler postulate states that the points on a line can be put into a one-to-one correspondence with the real numbers. Points on a line can be placed one-to-one with real numbers. So imagine these are all points and we could place real numbers to these points on the line, right? So here's a term that we've used before, absolute value. So absolute value has something to do with a difference between the coordinates of 2 points, right? And so what absolute value, do you know what this word is? The absolute value is the distance between any 2 points, right? It is the difference of their coordinates. So the absolute value of 2 and 5 would be found taking the difference. 5 minus 2 is 3. You could also take the absolute distance by saying 2 minus 5, which is negative 3, and take its absolute value, right? So the distance between A and B is the difference between A and B, and it's absolute difference. So we may subtract A from B or B from A and simply take the absolute distance. Let's find the lengths. Find the length of x, y. And you need this little note here that x is at 1.5, y is at 5. So if you were to expand this out, you could write it as the absolute difference between 1.5 and 5, or 5 minus 1.5, right? And when you do, you find that that difference is 3.5, or negative 3.5, and the absolute value of which is 3.5. Now find the length of xz. And you may have done it one of 2 ways, right? You may have found the absolute difference between 1.5 and negative 3. 1.5 minus negative 3 actually gives you a positive value, right, of 4.5. And the absolute value of 4.5 is 4.5. You might have also found negative 3 minus 1.5, which leaves you with negative 4.5, and that absolute value would also be 4.5. Now, what kind of segments have the same length? What word can we use to describe segments of the same length? And you, I'm sure, got it. It's congruent. So congruent segments have the same length. I have a pair of congruent segments here, and these little red marks are used to show congruent segments, but they don't have to be red. There's a little name for that, a little tiny name for that, and these marks are known as tick marks. So tick marks are used to show congruent segments. If segment PQ has 1 tick mark and RS has 1, those 2 segments are congruent. We could show a second set of congruent segments using 2 tick marks on both, right? and we could go on from there. We could have 3 tick marks on 2 segments, and it shows that those 2 segments, once again, are congruent. They must have the same number of tick marks to be congruent. Segments are simply portions of a line, right? 2 endpoints and the points between them. And so there are 3 methods to construct segments, and the first is probably the easiest: simply estimate and sketch. So if we were looking at PQ and I asked you to construct a congruent segment just by estimating, you could just even create a parallel segment to it and eyeball it and just try to make it look exactly like the same length as PQ. That's easy, and I'm sure you would be very capable of doing that. A second would be by measuring, draw by measuring. So we could take a ruler and measure PQ, know the exact length, and then just use that ruler somewhere else and draw the same length segment, right? And the third method is to construct. And when we say construct in geometry, we're talking about using a compass and a straight edge. So today you should have a compass and a straight edge, and let's walk through how we construct a segment. So you're being asked to sketch, draw, and construct a segment congruent to this MN. And so you should find a little space on your page to do this. So first we use a compass, and we extend the compass. We place the sharp point of the compass on one end and extend the pencil out to the other end, right? So now we actually have a distance. We have the compass spread into an angle that would form this length, right? And second, actually, I often do this first. You would use a straight edge just simply to draw a line. Just sketch out a line segment that you estimate to be longer than MN. And now place a point. You could call it S. Take your point of your compass, place it on S, and now the pencil can create an arch down on your line. And now you know exactly where point T should be placed so that segment ST is perfectly congruent to segment MN. So let me sum it up one more time before we leave. Probably you should begin by drawing a line that is a line segment that is longer than you think you need. You can see here, there's arrows on the end. And then you place a point on your line segment. Then you take your compass and you place the sharp end on point M, extend the pencil out to N, so you have that length of MN. Bring your compass back down, sharp end on point S, and draw an arch on your line. And now you know the location where you should create point T, and you have created a congruent segment. Okay, if B is between A and C, it follows that AB, segment AB plus BC, that measurement together equals AC. What might we call this postulate? Well, what operation are we using? Addition, and we're adding segments, right? So it's called the segment addition postulate. Let's use the segment addition postulate to find YZ. You may want to do a quick sketch. Y is between X and Z. So the longest segment in this example is segment XZ, right? XZ is 3. XY is 1 1/3. Find YZ. Go ahead, pause, come back when you're ready. So we know that XZ, the long segment, equals XY plus YZ. That's our segment addition postulate. Now what could we substitute here? We know XZ is 3 and we know XY. So we substitute the known values. And now we simply solve for the measurement of YZ using subtraction, right? We subtract 1 1/3 from both sides, and you should have YZ equals 1 2/3. Our final term to review today is midpoints. So when you think of a segment and a midpoint, what are you thinking? Yeah, cutting in half, right? So midpoints divide a large segment into two equal segments. They bisect. When you see bisect, something has been divided into two equals. In this case, segments. Okay? So when you come across the term midpoint or bisect, we're thinking two equal segments. You're 1,182.5 meters from the first aid station. What is the distance to a drink station located at the midpoint between your current location and the first aid station? Pause the video, come back and check your work. So we know that the distance from yourself to the first aid station is given. So the midpoint is going to be half of that, right? And so we can simply divide, which I'm sure you've done, divide the known distance by 2, or multiply by 1/2. Those are the same, aren't they? And you should have found 591 1/4, or 0.25 meters. Okay, it's time now for you to take your quick lesson quiz. You do this at the end of every lesson. Come back and check your work, and then you're ready to go. Number 1, 22.6. Number 2, 25, 25, and 50. And then please have myself or Mrs. Murrah check your constructed segment, okay? All right, and number 4, you should have found x is 3. And number 5, the statement is always true. And the sketch should look like this. If M is a midpoint of KL, then M, K, and L are collinear, right? And by definition, a midpoint would be collinear to the endpoints on the segment where you would find the midpoint, okay? And here is your assignment for Chapter 1, Section 2. Have a good time.